So first, let's think of a way how we doubled a number in our early school years. Okay, so we will do like a really simple and basic approach. For example, if we have a number 123 and we want to double it, we're gonna times it by 2. 2 times 3 is 6, 2 times 2 is 4, but we will write 4 with this indentation, and 2 times 1 is 2, and then we will add these numbers together. So this column is 6, this one is 4, and this one is 2. Okay, I don't know why did I write that. Okay, for another example, let's say 174 times 2, this is 8, this is 14. We write 4 here and 1 here, and 2 times 1 is 2. Okay, so it's similar with the above, it's just that we have this carry out digit, so we have to add it with 2 here. It's 3, 4, and 8. So basically and essentially, the simple way of double a number is just like doing the basic mathematical computing of it, and then just concatenate these numbers together. And if there's a carry out, make sure to add it with the digit in the same column. And that is also our approach. How can we simulate it on a linked list? Let's take the example that we did before, 1, 7, and 4 here. So let's say we want to double this number by 2, right? It's the same with this 174 times 2. Okay, so I will do this from left to right because previously we did it from right to left, but I'll do it from left to right just to be identical with the approach on the linked list. Okay, so 2 times 1, we write 2 here, right? Initially we write 2 here, and then when we get to the 7, we times 2 with 7, we get 14. We write it down like this. With 2 times 4, we get 8. Okay, and this is the same with this list here. At first we will go from left to right. 2 times 1 is 2. We will multiply it by 2. 2 times 7 is 14. What will we do now? If you look at this, initially we get the 2, right? The same, we get the 2, and then when we times 2 with 7 here, we see the result is 14, and then we rewrite the 4 in the same column, and then we sum the carry out, which is the 1 here, with the previous number, which is 2, which is 3, we get the 3 here. So we do the same on the linked list. We see that 2 times 7, okay, it's 14. It has a 4 as its value in here, and then it has a carry out. So we have to plus 1 in here, which is plus 1 here, it will become 3. And the remaining part is just really easy. 2 times 4, it's 8. We don't have any carry out, so we don't have to modify the previous node or anything. We're just gonna write 8 here. So yeah, just write 8 here, so it's the same. 3, 4, 8 here, 3, 48, it's the same, right? Okay, so with our code here, we will do like a different example. At first, we will create a carry out node, which is initially will also be the previous node, and that node is the node that has a value of 0 and points to the head of the linked list, right? 0 and points to the head of the linked list. And this loop here is basically just a linked list traversing method that you may be really familiar with it. So we initially assign current is the head, which is this node right here. We are standing here, right? We are standing here with our, this is current, and our previous node is here, right? So current points to the head of the list. And first we will get dB stands for double. dB stands for double, and with dB we will get like this value here, current dot value, which is 9. We'll time it by 2 and we will get like 18, right? We will get 18, and then we enter a condition. If our result is greater than 9, we will subtract the result by 10 to get the unit digit of this, and then the previous value will be added by 1, like just like the previous example that I've shown to you. So why do we have to like minus 10 here? Because as you look in the constraints here, the node value only ranges from 0 to 9. So when we double them, we're gonna get from 0 to 18. So our 18 here is like the maximum value we can get. So we have to minus 10, right? With like the numbers that have 2 digits, ranges from 10 to 18. So if we wanna get like this digit right here, we gotta minus it by 10, right? So that is our logic here, why dB minus 10. Okay, let's do a quick simulation. At first, we are at our head here. We are at our head here at the current node, and we want to calculate dB, which is the double equals the current value, which is 9 times 2 equals 18. And now we see dB is greater than 9, right? If dB is greater than 9, then we know that this contains 2 digits. So we have to subtract this by 10 to get an 8. And this 8 here is the same with this 8 here. So this is the digit in the unit column, and this digit will replace the current value, which will be 8, and then we will add 1 to the previous, which will become 1, right? Then we will shift our 2 pointers. We will shift, okay, so the current will become the previous, and the next of current will become the current. So these 2 pointers, it will shift here, and then we will do the same as we did before. With this current, we see that, okay, it's also a 9, so double is also 9 times 2, we get 18. We subtract by 10 to get the unit digit, and this 8 here is also will be the new current value, which is 8, and then we will add 1 to the previous node, which will become 9, and just do the same with the last node, which was, this will become 8, and this will become a 9, right? Here, dB subtracted by 10 is this one right here. dB subtract by 10, we get an 8, and then we modify it as the value of current here. The previous will be added 1, and then we will return like everything from the carry out to the end of the linked list. And with another example, like when we are at here, when current is at here, we will calculate the double, which is 2 times 2 equals 4. We know that 4 is smaller than 9, 4 is less than 9, so it contains only like 1 digit, so we don't actually have to subtract anything from this dB. We're gonna just assign this whole value as our new value right here, which is 4, right? So it's this logic. else right here, dB is less than or equals to 9, then we will modify the current value to be the dB. We don't have to subtract anything. Oh, and I haven't talked to you about this, which is the fact that we only return like the linked list including this carryout node when it is not 0, okay? When it is not 0, we will return the whole thing like from carryout and so on. But if this value is 0, like for example, if it's a linked list like 1 and then 2 and then 3, and let's say we have this as the carryout node, but we multiply this, we see that okay, when we come to 1, we multiply it by 2. There's no carryout in this situation, okay? There's no carryout in this situation, in this case. And then we see 2, we times by 2, we get 4, 3 times 2, we get 6. So in this case, we don't return everything starting from this node, but instead we return everything starting from the original head. That is why if this value is 0 right here, if this value is 0, we will return the head, which is this node right here. But if it's not 0, then we will return this one, because if this is greater than 0, it indicates that there is a carryout by this digit, and it's actually coming from 5 to 9 if you really think about it, because 5 starts with a 10 and 9 ends with 18 here. If it's a 4, it will, if 4 times 2 is 8, so it will not result in a carryout. But starting from 5, it's a 10 here, so we will get the carryout, and that is our logic.